April 22nd, 1944. 26,000 feet above Hamm, Germany. Hauptmann Heinz Knoke of Jagdgeschwader 11 rolled his Messerschmitt Bf 109 Gustav into a diving attack on a formation of B-17 flying fortresses. Knoke was no novice. He had flown over 400 combat missions since 1940. 67 confirmed victories decorated his logbook. He understood fighter tactics, aircraft performance, energy management. He knew that altitude meant life, that the pilot who held the height advantage controlled the engagement. What happened in the next 90 seconds would violate everything Knoke thought he understood about American fighters. A silver P-51 Mustang appeared below him, escorting the bombers at 23,000 feet. Standard procedure. Kate held 3,000 feet of altitude advantage. In every fighter he had ever flown, in every engagement he had ever fought, altitude advantage meant he controlled the engagement. He could dive, attack, and climb away before the enemy could respond. The heavier aircraft diving from above always held the energy advantage. Physics demanded it. Knoke rolled inverted and pulled through, diving toward the Mustang at over 400 miles per hour. He closed to firing range, his gun sight settling on the American fighter. But before he could fire, the Mustang pilot saw him. The American fighter's nose pitched up violently. The Mustang didn't turn away. It didn't dive to escape. It climbed. Straight up into Knoke's dive. Impossible. No fighter could climb that aggressively while maintaining control. The Mustang should have bled speed instantly, stalled, fallen away. Instead, it accelerated upward. Knoke watched in disbelief as the climbing Mustang closed the distance between them in seconds. He fired a brief burst, missed, then had to brake hard right to avoid collision. The Mustang flashed past his canopy, so close he could see the American pilot's face. Knoke pulled out of his dive at 18,000 feet, bleeding energy, trying to reposition. He looked up. The Mustang was already above him, gaining altitude, reversing for another attack. In 15 seconds, the American fighter had climbed from 23,000 feet to over 27,000 feet while simultaneously reversing course. Knoke's Gustav could not match that performance. Nothing he had ever fought could match that performance. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Mustang dove on Knoke from above. Now the American held the altitude advantage. The engagement had reversed completely. Knoke pushed his throttle forward, dove away at full power, and ran for the cloud layer below. He escaped only because the Mustang broke off to rejoin the bomber formation. When Knoke landed at Wunstorf airfield 30 minutes later, his hands were shaking. He filled out his mission report with unusual detail, describing the Mustang's climb performance. His squadron commander read the report and asked if Knoke was certain about the numbers. Knoke was certain. He had watched the Mustang climb over 4,000 feet in less than a minute while maneuvering aggressively. No piston-engine fighter should be capable of that performance. The report went up the chain of command to Luftwaffe intelligence analysts. They dismissed it. Their calculations showed that the P-51B model, powered by the Packard Merlin V1650 engine, could not achieve the climb rates Knoke described. The Merlin produced approximately 1,400 horsepower at combat power settings. The Mustang weighed approximately 9,800 pounds loaded for combat. The power-to-weight ratio allowed for good climb performance, certainly, but not the exceptional rates frontline pilots were reporting. German intelligence had made accurate assessments of American fighter capabilities throughout the war. They had correctly calculated the P-47 Thunderbolt's range limitations. They had accurately predicted the P-38 Lightning's high-altitude problems. They had properly assessed the early Allison-powered Mustang's inadequate high-altitude performance. Their methodology was sound. They examined captured aircraft, analyzed combat reports, consulted with German aviation engineers. They had no reason to doubt their conclusions about the Merlin Mustang's capabilities. They were wrong. What German intelligence failed to discover What Luftwaffe pilots learned through bitter experience was that the P-51's engine produced far more power than anyone realized. The Packard Merlin V1657, built under license from Rolls-Royce, was rated at approximately 1,400 horsepower at its standard combat power setting of plus 9 pounds of manifold pressure. But the engine had been designed with substantial safety margins. It could tolerate much higher power settings for limited periods without catastrophic failure. North American aviation and the United States Army Air Forces knew this. They had tested the engine extensively at war emergency power settings. At war emergency power, with manifold pressure increased to plus 25 pounds and engine RPM pushed to 3,000, the Packard Merlin V1657 produced 1,695 horsepower. That was 20% more power than German intelligence believed possible. 20% more power meant dramatically different performance characteristics. It meant climb rates exceeding 3,400 feet per minute at sea level. It meant the ability to accelerate vertically, to convert speed into altitude almost instantaneously, to outclimb any German fighter at combat altitudes between 15,000 and 30,000 feet. The Luftwaffe didn't know. Their pilots kept encountering Mustangs that climbed impossibly fast, that accelerated when they should have slowed, that fought uphill when they should have been forced downhill. Mission reports accumulated. Experienced pilots described engagements where Mustangs demonstrated performance that exceeded German intelligence estimates by wide margins. The reports were consistent, detailed, submitted by credible pilots with extensive combat experience. But without understanding the power available from the Merlin engine at war emergency settings, German analysts had no framework to explain what their pilots were experiencing. The consequences were immediate and catastrophic. Luftwaffe fighter tactics in 1944 depended fundamentally on energy management and altitude advantage. German pilots were taught to attack from above, use altitude to generate speed, make a firing pass, then climb away using their excess energy to regain altitude before the enemy could respond. This tactic had worked against every Allied fighter they had faced. Spitfires, P-47s, even early model P-51s could not match a Bf-109 or FW-190 in vertical maneuvers if the German pilot managed his energy correctly. The Merlin Mustang at war emergency power destroyed these tactics. A P-51 pilot under attack could advance his throttle and manifold pressure controls to war emergency settings and outclimb any diving attacker. The standard German bounce, dive from above and climb away, no longer worked. Mustang pilots would simply climb after the German fighters, catch them during their climb out, and shoot them down. German pilots began dying in situations where they should have escaped easily. Oberleutnant Franz Stigler of Jagdgeschwader 27 survived one such engagement on May 3, 1944. Stigler had 28 confirmed victories at that point. He understood air combat. He attacked a formation of B-24 Liberators from above, dove through the formation, destroyed one bomber with a well-placed burst into its wing route, then pulled up sharply to regain altitude. Standard procedure. He had executed the same attack profile hundreds of times. A Mustang that had been escorting the bombers at lower altitude climbed after him. Stigler watched the American fighter in his mirror, confident he would outclimb it. His W-190A8 had excellent climb performance below 20,000 feet. He was climbing at full power, converting his dive speed into altitude. The Mustang should have fallen behind, unable to match his vertical performance. Instead, it stayed with him. At 18,000 feet, still climbing vertically, the Mustang closed to firing range. Stigler had to roll hard and dive away, abandoning his altitude advantage to escape. He landed at Wiesbaden-Erbenheim confused and shaken. The Mustang's climb performance had exceeded anything he thought possible for a single-engine fighter. The technical explanation was straightforward, though German intelligence never discovered it during the war. The Packard Merlin V1657 incorporated a two-stage, two-speed supercharger. The first stage compressed incoming air, which was then cooled in an intercooler before entering the second stage for additional compression. This two-stage supercharging maintained manifold pressure at high altitudes, where normally aspirated engines would lose power dramatically. At 30,000 feet, where air density was roughly one-third of sea level, the Merlin's supercharger forced enough air into the cylinders to maintain combat power output. But supercharging alone didn't explain the engine's war emergency power capability. The critical factor was the engine's robust internal construction. Rolls-Royce had designed the Merlin in the mid-1930s, anticipating that future variants would require higher power output. The crankshaft, connecting rods, pistons and cylinder blocks were over-engineered for the power levels initially specified. This gave the engine substantial reserves. When Packard began manufacturing the engine under license in the United States, American engineers tested it aggressively, pushing manifold pressure and RPM beyond the conservative limits Rolls-Royce had initially established. They discovered the engine could tolerate plus 25 pounds of manifold pressure for 5-minute periods without failure. This setting, designated War Emergency Power, was approved for combat use in late 1943. Pilots were instructed to use war emergency power only when necessary, when being attacked or when attacking, to avoid excessive engine wear. But in combat, that limitation meant little. Pilots used maximum available power whenever survival demanded it. The performance difference was staggering. At standard combat power, plus 9 pounds manifold pressure, the Merlin produced 1,400 horsepower and pushed the P-51B to a maximum speed of approximately 440 miles per hour at 25,000 feet. At war emergency power, plus 25 pounds manifold pressure, the same engine produced 1,695 horsepower and pushed maximum speed to 465 miles per hour. More critically, climb rate increased from 2,800 feet per minute to 3,475 feet per minute at sea level. At altitude, where German fighters operated and where combat typically occurred, the performance advantage was even more pronounced. At 25,000 feet, a P-51 at war emergency power could climb at 2,900 feet per minute. A Bf-109 Gustav at the same altitude climbing at full power achieved roughly 2,300 feet per minute. An FW-198 managed approximately 2,000 feet per minute. The Mustang could outclimb both primary German fighters by 25 to 30%. In a combat situation, where altitude meant survival and energy management determined the outcome, that advantage was decisive. German fighter pilots throughout the spring and summer of 1944 reported encounters that their training and experience told them should not be possible. Major Gunther Rahl, credited with 275 victories primarily on the Eastern Front, transferred to defend the Reich in March 1944. He encountered P-51s for the first time on April 11th near Brunswick. Rahl was among the Luftwaffe's most skilled pilots. He understood energy tactics perfectly. He had survived hundreds of engagements against Soviet fighters by managing altitude and speed precisely. When he engaged Mustangs near Brunswick, his standard tactics failed completely. He dove on a P-51 from 28,000 feet, built up substantial speed in the dive, took a brief shot that missed, then pulled up into a climb to regain altitude. The Mustang pilot simply followed him up. Rahl climbed at maximum power, expecting to leave the American fighter behind. Instead, the Mustang stayed with him, matching his climb, then slowly began gaining. At 31,000 feet, with both aircraft climbing vertically and bleeding speed, the Mustang was still accelerating upward. Rahl had to roll away and dive, abandoning the engagement entirely. After landing, Rahl told his squadron commander that the American fighter had climbed from 23,000 feet to over 31,000 feet while maneuvering, without losing position. His commander asked if he was certain. Rahl was certain. He had watched it happen. Something was wrong with German intelligence assessments of the Mustang's capabilities. The aircraft they were fighting did not match the performance parameters they had been briefed on. Similar reports came from across the Luftwaffe's defensive fighter forces. Pilots described Mustangs that accelerated in climbs, that fought effectively above 30,000 feet where German fighters struggled, that could sustain vertical maneuvers that should have stalled any piston-engine aircraft. The consistency of these reports should have triggered a complete reassessment of German intelligence estimates. Instead, many reports were dismissed as pilot error, misidentification, or exaggeration under combat stress. The institutional failure to recognize the P-51's true capabilities cost the Luftwaffe dearly. Fighter tactics that had worked for years suddenly resulted in German casualties. Pilots who had survived dozens of engagements were shot down, attempting maneuvers that had previously ensured their escape. Young pilots arriving at frontline units with minimal training died within days because they were taught tactics that no longer worked against the aircraft they were actually fighting. The climb performance advantage manifested in multiple tactical situations. When German fighters attempted to thigh-thou, bounce bomber formations from above, escorting Mustangs could climb to intercept the attackers before they completed their diving pass. When German fighters dove away after attacking bombers, attempting to escape to lower altitude, Mustangs could follow them down, match their dive, then outclimb them when both aircraft pulled out. When German fighters attempted to climb away from combat to disengage, Mustangs could pursue vertically and maintain firing position throughout the climb. Perhaps most devastatingly, the Mustang's climb performance allowed American pilots to dictate engagement geometry. In air combat, the pilot who holds altitude advantage typically controls whether an engagement occurs. If you're above your opponent, you can choose to attack or not attack. If you're below, your opponent makes that choice. The Mustang's superior climb rate meant American pilots could force engagements on German fighters that were attempting to avoid combat, or could decline engagements by simply climbing away from German fighters that lacked the performance to follow. Lieutenant Colonel John C. Meyer, who would finish the war with 24 aerial victories, described the tactical advantage in a post-war interview. "We could fight uphill against anything the Germans had. If a 109 or 190 tried to bounce us from above, we'd go to war emergency power and climb into them. Most of the time, we could get our noses up to firing position before they completed their pass. If we were bounced and needed to disengage, we'd go to war, emergency power, and climb. Nothing they had could follow us up. It gave us options German pilots didn't have. We could choose to fight or not fight. They couldn't." The implications extended beyond individual engagements to operational-level tactics. By mid-1944, 8th Air Force fighter groups adopted increasingly aggressive tactics. Rather than staying in close formation with bomber streams, Mustang squadrons would range ahead, climbing to 30,000 feet or higher, then sweep designated areas looking for German fighters forming up for attack. When they found German formations, they would attack immediately, diving from above with the confidence that if the attack didn't succeed immediately, they could climb back to altitude faster than the Germans could pursue them. This tactic, called fighter sweeps, devastated Luftwaffe effectiveness. German fighters attempting to organize coordinated attacks on bomber formations would be hit by Mustangs before they could complete their assembly. The resulting combat would scatter the German formations, preventing the massed attacks that were necessary to penetrate bomber defensive fire effectively. Even if individual German pilots survived the initial engagement, their carefully planned attack was disrupted. By the time they could reorganize, the bombers had passed, or additional Mustang squadrons had arrived. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The performance advantage was not without limits. The Merlin engine's war emergency power setting could only be sustained for approximately 5 minutes before risking mechanical failure. Prolonged use at maximum power caused excessive cylinder head temperatures, potential detonation, and accelerated wear on internal components. Pilots were briefed to use war emergency power in short bursts, returning to normal combat power settings once the immediate tactical situation allowed. In practice, most combat engagements lasted less than 5 minutes from initial contact to disengagement. The limitations on war emergency power use rarely constrained tactics. Pilots would advance throttle and manifold pressure controls to maximum at the start of combat, fight aggressively for several minutes, then either disengage or reduce power once the immediate threat passed. Engine failures, due to war emergency power use, were rare. The Merlin proved remarkably durable even when operated beyond its design specifications. German fighter units attempted to adapt. Some pilots tried diving away at extreme speeds, hoping to build enough energy advantage that pursuing Mustangs couldn't follow. This worked occasionally, but it meant abandoning any attempt to attack the bombers. The mission became survival, not interception. Other pilots attempted to fight at very low altitudes, where the TEM-W190A8 had better performance than at high altitude. But bomber formations flew at 23 to 27,000 feet. Fighting at low altitude meant abandoning any attempt to reach the bombers. The most successful German tactic was to attack in overwhelming numbers, accepting heavy casualties among the first waves while hoping later waves could penetrate to the bombers. This required coordinating dozens of fighters from multiple units, launching them simultaneously, and directing them to converge on a single bomber formation. When executed properly, the tactic could succeed. Sheer numbers could overwhelm even aggressive Mustang escorts, but coordinating such attacks required time, fuel, experienced flight leaders, and reliable radio communication. By mid-1944, the Luftwaffe often lacked all of these prerequisites. Major Erich Hauptmann, the highest-scoring fighter pilot in history, with 352 confirmed victories, flew primarily on the Eastern Front against Soviet aircraft. He transferred briefly to defend the Reich in late 1944 and encountered P-51s for the first time. Hauptmann's tactics on the Eastern Front had been simple and brutally effective. Use altitude advantage, dive on an unsuspecting target, fire at close range, climb away. His success rate was exceptional because he chose his engagements carefully, attacking only when conditions favored him overwhelmingly. Against Mustangs, those tactics failed. Hauptmann described the Mustang as the only aircraft he fought that could counter his standard approach. When he dove from altitude, Mustang pilots would see him coming and climb into his attack. When he attempted to climb away after a pass, Mustangs would follow him vertically. After several missions defending the Reich, Hauptmann requested transfer back to the Eastern Front. He told his commanding officer that fighting P-51s required different tactics than he had mastered, and that learning those tactics would likely get him killed before he adapted. The psychological impact on Luftwaffe pilots was profound. For years, German fighters had held performance advantages over their opponents. The Bf-109 had been faster than Hurricane fighters during the Battle of Britain. The W-190A had outperformed early Spitfire models when it first appeared. German pilots had flown superior aircraft against inferior opponents often enough that they expected technical advantage. The Mustang reversed that expectation. German pilots now flew aircraft that were outmatched in critical performance parameters by an opponent that also had numerical superiority, better pilot training, and unlimited fuel supplies. Oberleutnant Heinz Knoke, the pilot who first encountered the Mustang's exceptional climb performance in April, kept flying combat missions through late 1944. His logbook entries from this period show increasing frustration. Multiple engagements where he held initial advantage, only to have Mustangs outclimb or outmaneuver his aircraft. Several close escapes where only luck or the Mustang pilot's error prevented his death. A growing awareness that the technical balance had shifted irreversibly against the Luftwaffe. Knoke survived the war, one of the few experienced German fighter pilots to do so. In post-war interviews, he identified the Mustang's climb performance as the characteristic that most surprised and disturbed German pilots. We had fought Spitfires, Thunderbolts, Lightnings. We understood their capabilities and developed tactics to counter them. But the Mustang could do things that should not have been possible. It could fight uphill. It could climb faster than we could at the altitudes where combat occurred. Once we understood that, We knew we were fighting an aircraft we could not match. The technical intelligence failure that prevented the Luftwaffe from understanding the Mustang's true capabilities had multiple causes. German intelligence collection methods had worked well earlier in the war when they faced British aircraft. The RAF was a relatively small organization. Captured aircraft were available for examination. Performance specifications sometimes appeared in Allied media or could be derived from combat observations, but American security was tighter. Detailed performance specifications for American aircraft rarely leaked. Captured Mustangs were often too damaged for thorough technical analysis, and the specific power ratings for war emergency settings were classified. Even when German engineers examined crashed or captured P-51s, they rarely discovered the war emergency power capabilities. The throttle quadrant and manifold pressure controls didn't have markings indicating the maximum allowable settings. Pilots knew to advance the controls to their forward stops in combat, but examining a static aircraft provided no indication of what power levels those settings actually produced. Without running the engine under load at various power settings and measuring actual horsepower output, the true capabilities remained hidden. The few times German engineers did test captured Merlin engines, they typically operated them at the conservative power settings specified in captured technical manuals. These manuals, intended for maintenance personnel, listed normal and combat power ratings, but often omitted war emergency settings for security reasons. German test reports consequently showed power output in the 1400 horsepower range, confirming their existing estimates. The actual 1695 horsepower capability remained undiscovered. By summer 1944, the performance gap between German and American fighters had become insurmountable. The Bf-109 Gustav and the Fe-190A8, both excellent aircraft when introduced, were now outclassed. German aviation designers worked frantically on improved models. The Bf-109K variant featured a more powerful DB605D engine producing over 1800 horsepower. The FOV-W190D9, the long-nose Dora, used a Junkers Jumo 213 inline engine producing 1770 horsepower and dramatically improved high-altitude performance. But these improved aircraft arrived too late and in insufficient numbers. The Bf-109K didn't enter service until October 1944. The BFW-190D9 began reaching frontline units in September. By then, the Luftwaffe's day fighter force had been essentially destroyed. Experienced pilots who could have exploited the improved aircraft's capabilities were dead. Replacement pilots with minimal training couldn't extract maximum performance from any aircraft, regardless of its specifications. Fuel shortages meant even brand-new aircraft often sat grounded for lack of aviation gasoline. The strategic bombing campaign's success depended fundamentally on achieving and maintaining air superiority over Germany. Without air superiority, bomber losses would remain unsustainable. Without sustainable bomber operations, the systematic destruction of German war production couldn't continue. Without destroying German war production, the planned invasion of Europe faced vastly higher risks. Everything hinged on defeating the Luftwaffe's fighter forces. The Mustang's climb performance contributed directly to that defeat by eliminating the altitude advantage German tactics required. A specific example illustrates the operational impact. On May 12, 1944, the 8th Air Force attacked oil refineries and marshalling yards across central Germany. Over 900 heavy bombers participated, escorted by more than 700 fighters, including the 357th Fighter Group's P-51s. Near Zwickau, Luftwaffe controllers assembled a formation of approximately 70 Bf-109s and Fe-W190, as from multiple units. The German fighters climbed to 32,000 feet, positioning themselves 5,000 feet above the bomber stream's altitude. Standard tactics: dive through the escorts, attack the bombers, climb away before the escorts could react. The altitude advantage should have made this feasible. The 357th Fighter Group, led by Lieutenant Colonel Donald J. M. Blakesley, spotted the German formation assembling. Rather than waiting for the Germans to attack, Blakesley led his squadrons in an aggressive climb toward the enemy formation. The Mustangs, initially at 26,000 feet, climbed at war emergency power. They covered 6,000 feet of altitude in approximately 2 minutes, arriving at the German formation's level before the Germans completed their attack positioning. The surprised German pilots found themselves engaged in level combat, rather than executing a planned dive attack. The Mustangs had eliminated their altitude advantage through sheer climb performance. What followed was a running battle extending over 60 miles. The German formation fragmented. Individual fighters attempted to dive away, but Mustangs followed them down. Others attempted to climb to regain altitude advantage, but Mustangs climbed faster. By the time the engagement ended, the 357th Fighter Group had destroyed 11 German fighters, confirmed with another 8 probably destroyed. They lost 1 Mustang. More importantly, the bomber formation they were escorting suffered no fighter attacks. Every German fighter had been engaged by escorts before reaching the bombers. This pattern repeated across dozens of missions throughout spring and summer 1944. German fighters attempting coordinated attacks would be intercepted by Mustangs that climbed into their formations before they could dive on the bombers. The psychological impact was severe. German pilots couldn't position for attacks without being attacked themselves. The tactical initiative had shifted completely. American fighters now controlled when and where combat occurred. The impact on Luftwaffe morale and effectiveness compounded over time. Each mission where German fighters were unable to reach the bombers reinforced the sense of futility. Pilots flew knowing they would likely be intercepted by superior aircraft before completing their mission. Young replacement pilots, arriving with minimal training, faced not just experienced American pilots, but also aircraft that outperformed anything the Luftwaffe could field. The death rate among replacement pilots was catastrophic. Many died on their first or second mission, never having time to develop the situational awareness and tactical judgment necessary for survival. Hauptmann Heinz Knoke, who had first encountered the Mustang's exceptional climb performance in April, continued flying through the summer. His unit, Jagdgeschwader 11, suffered devastating losses. Of the 42 pilots in his Gruppe in April, only 8 survived to September. The others were killed, captured, or wounded badly enough to end their combat careers. Knoke himself was shot down 3 times, bailing out twice and crash-landing once. Each time, he encountered Mustangs that climbed faster than his aircraft, that caught him when he should have escaped, that forced him into defensive situations where his experience barely kept him alive. In July 1944, Knoke wrote in his logbook after a mission near Hanover, "Attacked bombers from above. Good position. Destroyed 1 B-17. Climbing away, 2 Mustangs came up from below. I had 3,000 feet advantage and full power. They caught me anyway. Climbed straight up at me. I had to roll and dive. This should not be possible. Their aircraft is simply better than ours." The technical advantage extended beyond climb rate to sustained turn performance and high-altitude capability. The Merlin engine's 2-stage supercharger maintained power output at altitudes where German engines lost effectiveness. Above 28,000 feet, the Bf-109, Gustav's DB-605A engine produced significantly reduced power. The aircraft could still fly at these altitudes, but climb rate, turn rate, and acceleration all degraded. The Mustang maintained near-optimal performance up to 32,000 feet. This altitude advantage allowed Mustang pilots to position above German formations, with confidence that German fighters couldn't effectively counterattack at those heights. American pilots learned to climb above 30,000 feet when escorting bombers, forcing any German attackers to either climb to unfavorable altitudes or accept attacking through an escort screen positioned above them. Either choice put German pilots at a severe disadvantage. Lieutenant Urban L. Drew of the 361st Fighter Group demonstrated the altitude advantage dramatically on October 7, 1944. Drew was escorting bombers near Berlin when he spotted 2 Messerschmitt Tu-62 jets at approximately 32,000 feet. The Me-262 was substantially faster than any piston-engine fighter, but the jets were climbing slowly, apparently low on fuel, and trying to reach altitude for an attack on the bombers. Drew climbed his Mustang at war emergency power, gaining altitude rapidly, despite already being at high altitude where most aircraft's climb performance degraded severely. He reached 33,000 feet and positioned behind the two jets, which hadn't seen him. The Me-262s were climbing at perhaps 500 feet per minute, their fuel state apparently critical. Drew closed to firing range and shot down both jets in quick succession. The engagement demonstrated that even against jets with substantial speed advantages, the Mustang's climb performance at altitude provided tactical options. The systematic destruction of the Luftwaffe's day fighter forces through summer 1944 resulted directly from the combination of numerical superiority, better pilot training, and aircraft that outperformed German fighters in critical parameters. Of these factors, the aircraft performance advantage was perhaps most psychologically devastating to German pilots. They could understand being outnumbered. They could understand that American pilots received more training, but they had expected to fly aircraft that were at least competitive technically. The Mustang shattered that expectation. German fighter production actually increased through 1944. Despite Allied bombing, despite raw material shortages, despite transportation difficulties, German factories produced over 25,000 single-engine fighters during the year. But these aircraft couldn't be effectively employed. Fuel shortages meant many never flew operationally. Lack of trained pilots meant others sat unused. And even when both fuel and pilots were available, the aircraft's performance disadvantage meant they faced severe losses in combat. The fuel crisis particularly crippled Luftwaffe operations. Allied bombing targeted synthetic fuel plants systematically through summer 1944. German aviation fuel production dropped from over 180,000 tons in April to 30,000 tons in September. This forced severe rationing. Fighter units received minimal fuel allocations, barely enough for essential missions. Training schools received almost nothing. Advanced training that required extensive flying hours became impossible. New pilots arrived at operational units with as little as 110 hours total flight time, including their basic training. These undertrained pilots flying inferior aircraft against experienced American pilots in superior aircraft produced predictable results. The casualty rate among new Luftwaffe pilots exceeded 80% within their first 5 missions. Most died without ever shooting down an enemy aircraft. The experienced pilots who might have mentored them were dead. The aircraft that might have given them a fighting chance were outperformed. The fuel that might have allowed proper training didn't exist. By late summer 1944, some Luftwaffe units had more aircraft than pilots. Jagdgeschwader 3 reported in August that they had 48 operational Bf-109s and Fw-190s, but only 27 pilots cleared for combat. The other 21 aircraft sat unused. Similar reports came from units across the Reich Defense Forces. Germany could build fighters faster than it could train pilots to fly them, and the pilots it did train were often killed before gaining useful experience. The final major defensive effort by the Luftwaffe's day fighter forces came on September 11, 1944, when Luftwaffe units launched approximately 170 sorties against 8th Air Force bombers attacking industrial targets across Germany. The Germans managed to shoot down 7 bombers but lost 45 fighters. The exchange rate was catastrophic. The Americans lost less than 1% of the attacking force, while destroying over 1/4 of the defending fighters. Multiple factors contributed to these lopsided losses, but the Mustang's performance advantage played a critical role. German fighter formations attempting to organize attacks were intercepted by Mustangs that climbed rapidly to engagement altitude, scattered the German formations before they could coordinate their attacks, then pursued individual German fighters that attempted to escape. The tactical geometry that had allowed Luftwaffe fighters to survive when outnumbered used altitude advantage to control engagement Attack quickly, escape by diving away no longer worked against an opponent that could climb faster. Hauptmann Heinz Knoke flew his last combat mission on December 16, 1944. By then, Jagdgeschwader 11 had been reduced to fewer than 15 operational pilots, from a strength of over 60 just 8 months earlier. Knoke himself had been shot down 5 times since encountering his first Mustang in April. On December 16th, he was bounced by 4 P-51s while attempting to intercept bombers near Osnabrück. The Mustangs dove on his formation from above, then climbed away after their initial pass before Knoke and could counterattack. He attempted to chase them, but they outclimbed his full 190 at full power. Frustrated and low on fuel, he returned to base. It was his last flight. His unit was withdrawn from combat operations shortly afterward due to lack of pilots and fuel. Knoke survived the war, unusual among Luftwaffe fighter pilots who flew continuously from 1940 through 1944. In post-war interviews, he was asked what single factor most contributed to the Luftwaffe's defeat in the air war over Germany. His answer was direct: the P-51 Mustang. Specifically, its climb performance. We couldn't escape from it. We couldn't catch it. We couldn't position above it. Once we understood its capabilities, we knew we couldn't win. Other German pilots offered similar assessments. General Adolf Galland, who commanded the Luftwaffe's fighter forces through most of 1944, stated after the war that the Mustang's appearance over Berlin in March 1944 marked the beginning of the end for the Luftwaffe. He noted specifically that the aircraft's combination of range, speed, and climb performance created an operational situation the Luftwaffe couldn't counter with available resources. Oberleutnant Franz Stigler, who survived over 400 combat missions, said in a post-war interview, "The Mustang was the best piston engine fighter of the war, not because it was faster, though it was fast, not because it was more maneuverable, though it turned well, because it could climb. That climb rate at altitude meant it controlled every engagement. The pilot in the Mustang decided if he wanted to fight or run. We didn't have that choice." The technical specifications that German intelligence failed to discover during the war became public after Germany's surrender. When Allied technical intelligence teams examined German assessment reports and captured intelligence documents, they discovered that German estimates of P-51's performance had been consistently wrong. German intelligence had calculated climb rate at approximately 2,600 feet per minute. The actual rate at war emergency power exceeded 3,400 feet per minute. They had estimated maximum horsepower at 1,400. The actual war emergency rating was 1,695 horsepower. These errors compounded German tactical failures. Pilots flew missions based on intelligence briefings that understated their opponent's capabilities by 20% or more. They attempted tactics designed for fighting an aircraft that didn't exist. The real Mustang they encountered was faster, climbed better, and fought more effectively at altitude than they had been told to expect. The psychological impact of repeatedly encountering an opponent more capable than intelligence indicated was devastating to morale and confidence. The irony was that German engineering could have produced comparable performance. The DB605D engine that powered late-model Bf-109 variants was capable of over 1,800 horsepower at emergency power settings. The Junkers Jumo 213 inline engine in the Fe-190D9 produced 1,770 horsepower. Both engines could have powered fighters competitive with the Mustang. But these engines and aircraft entered production too late, appeared in too few numbers, and arrived when the Luftwaffe no longer had the fuel or pilots to employ them effectively. The strategic impact of the Mustang's performance advantage extended beyond individual air battles to enable the entire Allied air campaign over Europe. With effective fighter escort, bomber losses dropped from unsustainable levels above 8% per mission in late 1943 to acceptable levels below 3% by summer 1944. This allowed sustained bombing of German industry, transportation, and fuel production. The bombing campaign systematically destroyed Germany's ability to wage war. Without the Mustang's capabilities, the bombing campaign would have failed or been so costly as to be unsustainable. Without the bombing campaign succeeding, Allied air superiority over Western Europe couldn't have been achieved. Without air superiority, the D-Day invasion would have faced vastly higher casualties and risked failure. The chain of causation was direct. The Mustang's technical advantages, including its exceptional climb performance, enabled strategic success. By April 1945, the Luftwaffe had ceased to exist as an effective fighting force. Individual units still flew missions, but organized defense of German airspace was impossible. Fuel was essentially unavailable. Experienced pilots were dead or too exhausted for combat. New pilots arriving at operational units had less training than peacetime student pilots. The aircraft, even the advanced models, sat grounded for lack of fuel and pilots. On the last day of combat operations in Europe, May 8, 1945, the 8th Air Force flew 700 bombers over Germany without losing a single aircraft to enemy fighters. The Luftwaffe that had terrorized Europe in 1940, that had seemed invincible over France, that had nearly defeated the Royal Air Force over Britain, had been completely destroyed. Multiple factors contributed to that destruction, but the P-51 Mustang's technical superiority was decisive. The Mustang proved that aircraft performance, specifically climb rate and high-altitude capability, could be more operationally significant than raw speed or firepower. It demonstrated that range, the ability to be present anywhere in the combat theatre, was more valuable than any other single characteristic, and it showed that technical advantages, even relatively modest ones like 20% better climb rate, could compound into overwhelming operational superiority when combined, with numerical advantages and better training. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.